Hello?
Yes, we can hear you.
Hello? Can you hear me?
Yes, we can.
Okay, good. You can see my slide. Hello?
Yes, we can.
Yes, it's visible.
Okay. Then I'll start. First of all, thank you to PJAC for having me. It's an honor to be here. Without further ado, we'll begin. Just a quick question to Mr. Jim. Is the link that you shared in the group, is it the same one that people visit with? Are we allowed to share that link? Mr. Jim?
Yes, can you come again with your statement?
The link you shared in the group, are we allowed to share that one for people to join?
Yes, it's for everyone.
Okay. I'll start. Okay, so just before we begin, I thought it would be fun if I introduced a little joke for the programmers. So you can read it. For those of you who are new, you might not understand this. It's an insider joke, but for every programmer, we all know what this means. So I thought it would be fun if I put it in here. Without further ado, let's begin. So the agenda today will be for me to introduce what software engineering is, just a recap, since we already had the presentation by Jules on software development. And then I'll take us through what a front-end developer actually does in their day-to-day. And then from that, the core technologies that we use in our daily life as front-end developers. And then I have something special at the end. So we'll begin. So software engineering is just the entire development process of coming up with an idea of your software product, designing it, not just how it looks, but the core functionality as well, and then actually coding it and shipping the product. So there's a bunch of other stuff involved, such as testing and maintenance, but the entire process would be categorized as a full stack process. Now, in order to understand that full stack process, you have to think of it as a stack of plates. So when you have, let's say, 3 plates, with the bottommost plate being the database, the middle one being the server, and the top one being the client, which is your browser, then you would say that the topmost plate is what people are presented with, since it's the only one they can see. Everything else in the middle and at the bottom is not visible. So if you think of the full stack as a stack of plates, then each stack has its own responsibilities and its own, each stack has its own disciplines involved. Now, generally speaking, I would recommend that everyone knows the full stack, but since this presentation is on front end, I'll be focusing on the front end. So the topmost layer of the stack, which is what people see, which is what people interact with. The server side is the core functionality of your app. So when you're making requests or when you're purchasing something, the actual code that makes, let's say on Amazon, that sends the request to the computers at Amazon to label your purchase and add it to the cart, then that would be the server side and the database. So we call this the back end. And everything else that people see, that would be the front end. Just before I continue, did you get that? Anyone? Hello?
Yes,
Did you
we
get?
get that one. Yes.
Okay. Okay. Thank you. So
If wait, if there is anyone who has a question or type on the chat, so you can just proceed until just check on the chat. If there is anyone who has a question, you see on the chat.
okay. So what do we actually do as front-end developers? Well, we design the entire experience and we code it as well. Now, for this presentation, I'm assuming that we have a mixed audience between people who are already familiar with programming and people who are new to it. So with that in mind, I just want to say that I'm also looking at this presentation from the perspective of a freelancer, more than just a person who's working at a company. Because in a company, generally, you're split into teams and each person has their own responsibility. So the majority of this presentation is me looking at you as a freelancer and not just someone who's been delegated a certain type of task. So I'm assuming that you're handling everything on your own. So front-end development revolves around three main technologies, which is HTML, CSS, and JavaScript. These are programming languages, this one being the primary programming language, and these ones are not necessarily programming languages, but they are very important when it comes to web development in the front end. So just to answer the question of why we're very important, why can we just focus on the back end? Imagine if you were shopping on Amazon and you had to use this, which is a console that doesn't have images. All you have to do is put commands, and the commands would take you to separate directories or folders, and then you would have to add another command to buy something. This instead, a new discipline emerged where we can see the actual products we're purchasing, where we can actually search and have a list of items the one we're searching show up for us. And that's why we're very important, because it adds to the experience and makes it more intuitive and engaging than using the console. So what a front-end developer generally does is we collaborate or work with back-end developers and designers. So the back-end developers are usually working on data that we'll be using. They're working on the database and the server. And the designers are working on a bunch of things such as the colors we'll be using, the actual designs in terms of how the user interface will look. So the text, the typography, and other stuff like that. But if you are a freelancer, then you are actually working on every single thing here by yourself. So you are the designer as well as the developer. So as front-end developers, we then code the interface and we make sure that we are accounting for responsiveness. So this means that you're developing for multiple types of screens in terms of real estate, in terms of their screen, in terms of the device size. And we're also accounting for our accessibility. So if you have, let's say, blind people, web browsers today, they have text to speech. So a person could just press a button for them and they'll be able to, the web browser can read the contents out for people. And you also have to optimize for performance. Every website has to load fast on every type of device. So we are working on all of this. It's not just coding. We're working for different types of mediums and thinking of different types of scenarios. So the beginning of the development stage starts with a simple design where we create what are known as low and high fidelity designs. So a low fidelity design is usually you just grabbing a piece of paper and designing very simply what you want your user interface to look like. So this is known as low fidelity, and it's called low fidelity because we don't account for functionality. We just want to see what it would look like in terms of layout. So we focus on the device we're developing for, the core components, and the core text, such as here you have shop. If you see these lines here, we just put them, though that's actually going to be text in the final design. But since it's not very relevant right now, we just put the lines or squiggly lines if you're using that. Now, this is actually not just as simple as it sounds. It's very complex because you have to adhere to a design language. For example, if you put a box with an X, that means that's a picture. If you put a circle with a human in there, this human figure, that means that's a profile picture. So this is actually a design language that people adhere to. It's got standards of its own. So the low fidelity only focuses on user flow, how users go from one page to the next. But there is no functionality because remember, this is on paper, so you can't actually press a button and be taken to the next. But you can color it like this and this to sort of show that you can click this and go to this page. Now, high fidelity designs take this step to take this process to the next step by actually including the design, the interactivity of the app. So you prototype it using special software. Now you add the features you initially worked with on your designs you made. So that will be incorporating the color, the icons you made. All of this comes together in high fidelity. Now, even though it's functioning, even though it, as you can see here, even though it's changing based on the layout, based on the device, it's not actually a functioning prototype in terms of the data being produced. You can't actually order anything. Like in this example, you can't actually order a cupcake. This is just an interactive prototype that shows how the final thing is actually going to look like. So this process is very important because this is where we make the final tweaks before you can send the design to the developers. So we focus on the user experience, UX for short, and we also focus on the feedback loop. So if you're a freelancer, this is what you would send to your client. You would send the high fidelity, not the low fidelity. That's for you, and that's for the initial stage. But you would send this to your client so that they can approve it. So you can see it's not just coding. There's actually a lot that goes on at the beginning of the entire process. And we focus on the components. Now, these assets here, these pictures, this is actually stuff we're going to use in the final phase of making the website. So just a recap on the differences between low fidelity and high fidelity. This is on paper. There is no interaction. It's quicker to ideate, and it encourages innovation. While high fidelity is computer-based, use special software such as PewDiePie, and I'll show you some other example. But this actually has interactivity. So if you press a button, you can actually go to the next page, but there isn't actual requests being made to the database, nothing like that. And this is the most important part of high fidelity. We can indicate THP. So THP stands for True Human Performance Data. So you have to understand that, let's say we are creating an account for an app. No, we're creating an account for a user in our app. It would take, let's say, if it takes 10 steps for the user to create an account, that's a very boring user experience, believe it or not, because by the 5th step, when the user is creating the account, they could log off of your account. They could just log out of the app or just uninstall it. So THP indicates the time it takes for a user to interact with features on our app, the time it takes a user to move and navigate in our app. So with high fidelity, it's easy to incorporate THP in our design so we can actually see how long it takes users to do certain tasks. And as I said at the beginning, it demonstrates the actual products look. So if you guys want to learn more about it, I would go to wireframing. This is a free course. It has certification. This will teach you low fidelity. They will teach you everything. It's on allison.com. And these two here will teach you the basics of web design and Figma. So Figma is another tool that you use for high fidelity prototypes. This is what we can use to actually create actual interactive prototypes. Can I go to the next? Okay. So the next phase would then be to use core technologies to build the actual website. So this is where we start to use the designs we've just received from the designers. And then we take it to front-end developers. So that's our job. The developers are us. And then we use core technologies such as HTML, CSS, and JavaScript. So HTML stands for Hypertext Markup Language. So it's a markup language, meaning that it's mostly actual words in there. It's just text. It's text. It's mostly human readable language. It's not a bunch of jargon. CSS stands for Cascading Style Sheets. So if this is the skeleton, CSS would be the paint. This is what we use. And JavaScript would then be the engine. This is what we use to add interactivity. So these three core technologies work for all browsers. So whether it's Chrome, Safari, Opera, it's no longer supported Explorer, it's Edge now, and Firefox. So let's see what HTML5 is. So now that we have our designs, we would use a language, a programming language like HTML to add the actual content. So this HTML is used for adding content. So we're putting our important content onto our web pages. These are documents. This is what the internet used to look like initially. It was just text, but in the back end, this is what it actually looks like. So HTML is a document type language. So you use tags, which are special elements to put content onto the web page. So the head, this is where we have special information. It's called metadata. So this information is not viewable to users. This is just for browsers to use for search engine optimization and other stuff like that. The content we are concerned with lives in the body. This is what the users will be presented with. And these are called element tags. They define our content. Now, HTML comes with a bunch of tags. So you have text for putting text like headings and paragraphs. You have multimedia for putting things such as video, audio, and images. You have forms, what we use to get input from users and generate data. And then you have layout, which is used with CSS for making responsive designs. But also HTML has access to the browser's API, so we can actually draw images. And this is why you also have like video games on browsers, because the browser actually has an API, and I'll explain API later. But these graphics, they're used to draw, and Canvas allows us to use SVGs and other code to draw images. So this is just a list of some of the tags being used. So you can see how they are used. We have headings. These types here are these ones. And then you can also make lists. So you have an unordered, which means there's no hierarchy, but then you also have ordered, which means there's hierarchy. And then you have examples of links. So on a web page, when you press a link and then you're taken to another page, this is what it actually looks like in code. It's just an anchor tag. We use the A, and then this is where you put the link. It's called an hyper reference, and then this is just that. But you also have headers. So for, let's say you have a section with an article that you want to have a heading, then you would use something like that. But you also have navigation. So this is pretty boring the way it looks. This is not what you would actually work with in terms of presenting to the user. I just wanted to show you guys what the code looks like. So here we have working with video. It's an actual, so this is what I meant by it's human readable. It's an actual tag with the word video, and you would actually put video there. An image has IMG, and there will be an image somewhere, an audio there. So you see, HTML is human readable. The form, this is what you're presented with. It's a simple form. So you guys don't have to memorize this. I just wanted to show you. But HTML gives us the ability to put all of these things together so that users can be presented with information that's useful. So now that we have our HTML, what do we do with it? Well, we take the HTML and we pair it with CSS. So CSS is our styling sheets. This is what we use to paint our vehicle. Right now we have the skeleton with HTML. It's boring, it's ugly. We use CSS to paint our vehicle. Now the reason is why we're using CSS, the reason why we would use CSS is it allows us to separate our styles from our actual content. If you had the content in the same page, it would take up a lot of space. So you have to remember that document files can also take up a lot of space based on the text that's in them. So we can split it up, and that allows us to have consistent styling throughout a page. So we can make themes with that's why you have websites that have a certain type of color, like a blue that's only like theirs. So CSS is at the forefront of this. We're creating themes and our own style of painting our web pages with CSS. It's flexible. It allows us to make responsive designs which can fit on all devices, on all types of screens, and it's in a more efficient way. So CSS looks like this. It's sort of similar to HTML, but it has its own syntax to it. It's a selector-based language. So what that means is if you see here, if you see here, these things, these are selectors. So you have to tell CSS to grab the actual element that's in your HTML. So this is a selector. What we're doing here, we're selecting an element based on certain attributes. So this is an ID. This can only be used on one element. It's denoted with a pound symbol. And in HTML, it's denoted with an ID. I'll show you later. But a class is something that can be used on many elements. So just so you remember, for future reference, just so you remember. So just so you remember, sorry, I had to answer someone. Just so you remember for future reference, a class can be used on many elements, while an ID cannot be used on, or can only be used for one element, on one element. So what we do is we take those selectors and we give them properties. We give them properties to define our style. So inside here, that's where we're actually having our style. So with CSS, we can select elements and style them according to what our theme is. So let's look at an example here. I have a simple profile page here that just shows my name, my profile picture, some fun facts about me, and an input element here with a button that allows users to sign up for my newsletter. But we also have a link here to my LinkedIn. Now, this could be, this could be a proper profile page if you want to. This is what you could send to users if you need to. But in today's age, users are used to prettier profiles. So with CSS, we can take this a step further. I'm using basic elements, so just like a button, an input, a paragraph, a list, the basics I showed you earlier, an image. But I'm also using the ID. So remember in CSS, I said you can use an ID to define it in CSS to sort of point to it. That's how you would use it in HTML. And we have a div. I'll explain this later. With CSS, we can take that code and add a style sheet to it. So in HTML, in the head, you would use a link. Now, in HTML, the two ways in which you would add CSS, but I used this one because this was what you would actually use in real life. The other way is it's useless and it takes up a lot of space. So I chose to leave it out because this is what you would actually use in the industry. So using CSS, we add it like that. This defines the relationship, it's short for rel. It's the type of relationship, a style sheet to the HTML that's been added to in the head, and then the actual name of the file. And then this is just our CSS. Obviously, there's more down there and up there, but the outcome of that CSS that I added is this. So this is way better than this because this image was just too in your face. It was very large, but this is way better. So in HTML and CSS, what you have to understand is everything is actually within a box. So you might not see it here, but in HTML and CSS, in HTML and just web development generally, everything is within a box, and this is called the box model. It's very helpful when you're working with CSS because it helps you understand your designs better, and I'll show you why. But everything is within a bounding box that defines its margin, which is just a space between the element and another element somewhere. The border, which is just the line surrounding the element. The padding is the space within the element. And then the content is what you would see. So if I had a paragraph, the text would be this. But you have to think of every element in HTML as something that has a box, an invisible box around it. So what do we do with this information? We can actually create responsive designs with that. So using CSS and that information of the box model, you can use a style like display. You don't have to memorize this, but you can use a style like display and flex, which can actually create different layouts based on the screen. So this would be a desktop, and then this would be what you would see on a mobile device. So you see with that information of the box model and this and the information and the knowledge of CSS, you can create responsive design. It's that easy. So block would be the line, and then flex. Block would be the line, and then flex would allow us to create this if you use the direction. So in CSS, how we create responsive designs is we use media queries. So media queries allow us to specify the width of a screen and the height as well. But generally, we're talking about width. So if you can see here on the example image, we're defining our width, the actual screen in pixels, that is. So 1200 pixels would be something very large, like a TV or something, or a laptop screen. And 10, you've got 1024, 7 something, until you have a phone here. So with CSS, it allows us to create one web page with different layouts depending on the screen. That's why you have to have CSS paired with HTML. If you use HTML, it's going to be boring. CSS was specifically made for HTML. It's not used with any other language. It was specifically made for HTML. So with that, you could take just how CSS is and HTML and make your websites. But that isn't just how CSS is actually used. In the real world, CSS is generally used with preprocessors. So these are just like extra features of CSS that we can add on top of normal CSS. For example, in a programming language, a normal programming language, there's the concept of variables. You can watch the software development presentation earlier by Jules, where he explained what they were. But here, I'll just say them again. Variables are like containers you use to store data. With CSS, well, you can do that as well. You can create variables at the top of your file using this preprocessor SCSS, and then use the variables within your styles here. When you are building the website, at the end, when it compiles down to normal CSS. Now, the reason we're doing this is, imagine if you had other elements down there, let's say 100 elements that are using the color seashell. Yeah. Someone has their audio on. Okay. So imagine if you had other elements down there that are using the same color. You would have to change the color on every single element down there, on every single selector, which is time consuming. So with preprocessors, we can create variables and a bunch of other features. In this instance, we can just change the color here, and it would change for every single other element that's using primary color. So that's why it's important. And there are different types of preprocessors, like SCSS you can use. Now, with preprocessors, we can actually create the themes I was talking about. So our buttons can have the same color depending on the functionality. So if you have an apply button, a buy button, you could have different colors, and that would create like a overall theme. And that's why you hear things such as frameworks. So these are the most famous frameworks in the market: Bootstrap and Tail in CSS. This one is like the OG one, the older one, and Tail in CSS is the new one, the new kid on the block. But these were actually made with preprocessors. This type of CSS. So this one was made with SAS, and this one was made with post CSS, but it works the same way. Now these frameworks are actually very important because they allow us to create themes so that we don't have to recreate the colors and the buttons and how they look on every single page. And we can create the theme in just, let's say, 4 CSS files, and we can use those files on any other project that we want. So we create the theme once, we create the styles once, and we can use them in any other future project. So this is how Bootstrap looks like. You just define the class. Remember, the class can be used on any element. It can be used on many elements. And the same for Tailwind. So instead of you having to write the CSS on your own, like a million times. So for example, let's say on Amazon, which is a web application that has a million lines of code, instead of having to create millions of lines of code for us as freelancers, we can use frameworks, which is code someone else wrote, themes that other people made, and we can use that. All we have to do is just call the class, and we won't even have to bother with the CSS. All we have to do is use the right class, and you would have nice layouts, nice themes, nice colors, and nice designs like this. So now that we have our skeleton, we have our paint. What do we do with our websites? Right now, they're just sitting there. They're boring, and they're not doing anything. If we press a button, it doesn't do anything, right, on our website. That's where JavaScript comes in. So you can think of JavaScript as the engine. This is what breathes life into our web page. This is what we're mostly concerned with as front-end developers most of the time. The designs are okay. HTML and CSS are there, but they are lifeless. JavaScript will breathe life into the website. So JavaScript is an actual programming language. It's different from HTML and CSS, which are style-based and content-based languages. JavaScript is an actual programming language. It can be used for any other some other purposes, but JavaScript is a primary language that runs on the browser. So any browser that you have is running JavaScript. It's the only language that can actually run on a browser. So the main three languages that run on the browser are HTML, CSS, and JavaScript, the primary ones. There are other languages such as WebAssembly, but generally when we're speaking of client side, we're talking about the main three: HTML, CSS, and JavaScript. Now it's important because it's versatile. Like I said, you can't just use JavaScript on the client. These days you can on the backend as well. It's dynamic, so its key feature is adding interactivity to our web pages. It allows us to run a bunch of scripts. For example, making requests, not just making buttons interactive and clicky, but making requests. And it has a vast ecosystem. So if you're stuck on something, let's say you're writing code in JavaScript, JavaScript has a vast community. So the frameworks community where you can ask any question and you get answers quickly to your problem. So it's very cool because the community is large. Now JavaScript, like I said, is an actual programming language, which means it's got an actual programming language here. If a person who doesn't know programming looks at this code, they might make sense of it, maybe because it's English, but the actual functionality of what it does, they won't be able to actually understand unless they've learned the syntax and the rules of JavaScript. So you don't have to, again, memorize this. This was just an example. But the syntax of JavaScript is the rules that you have to adhere to. X means the actual rules and conventions that dictate how you write the code using that programming language. So in JavaScript, we can create variables, which are just containers for storing information. And a statement is just this, the expression that evaluates to something. So if we create a variable X that holds 5, and we close it with this semicolon, this is a statement. So in JavaScript, we can create different types of numbers, strings, also create objects and arrays. An array is like a container that can hold multiple items, but it's got an index to it. An object is a real-world representation of something. So for example, I have a person here, and we can add name and then the person's actual name. This is called a key value pair. So what you have here is the key, and this is the actual value. So an object is a key value data structure or a key value container. And in JavaScript, we can also create functions. So with the car analogy that I was using in the engine, so the engine's functionality is to turn the tires spinning so that you can actually move. So you can think of functions as little blocks of code that initiate the car. For example, you could have a code that says turn on lights, and then when the key is turned, turn on the engine. When the steering wheel is turned to the left, then turn left. Functions are just code that we use to call. That we use to call when we are achieving a certain action or task. So again, here is a here's the object. Now, just to differentiate between making functions as well. Remember, an object is a real-world representation of something, right? In code, in JavaScript. So here we run. So you can. This is what we work with when we are generally talking about data. So, for example, on Amazon, you could have a user ID as the person here, and then you could have an ID there, name. You could have their location, and then you could have an array of the items they have. So an object is very versatile and very important, which are just ways of saying if something happens, something else should happen. But if that doesn't happen, something else should happen. And these are called if-else statements. So if the weather is sunny, then you say it's a beautiful day. If it's cloudy, it's a gloomy day, and or else, which means if none of these are true, then just say something else. So this example is simple, but you can think of this as something that's very powerful. For example, if the user is logged in on Amazon, then but if they're not logged in, then they can just, sort of window shop on Amazon. They make a purchase unless they're logged in. So you can see with this simple if-else statement, you can actually be versatile. So here's another example of JavaScript. So here I took the profile we made earlier with HTML and CSS. Right now, it doesn't have JavaScript.